but I was having a little problem in my connection. Am I audible now?
Yes, ma'am. Yes, ma'am.
All right. Okay. So, any introduction from IIG for the participants?
Yes, ma'am. Yes, ma'am.
Yeah, please. Uh, Neeraj? Yeah.
Neeraj, my voice is audible?
Yes, sir. Audible, sir. Yes, sir. Audible, sir.
Okay, okay. Good morning to all the participants and our today's faculty, Mrs. Minimal Korulla ma'am. She is Vice President in the Meccafferi. So all of you know that we are conducting this online training program on surface and subsurface drainage management from 22nd of August. So today is the second day of this ongoing training program. Yesterday we have already discussed on the requirement and overview of drainage and hydrological design of roadside drain. So today we will discuss on the subsurface drainage and groundwater recharge. In that we will discuss on the sources of moisture in lower layer of the pavement, treatment of subsurface moistures, GSV drainage layer, geosynthetics composites, fin drain, subsurface drain for intercepting sewage water in hill terrain, capillary aggregate drain, groundwater recharge arrangement, check dam, percolation tanks, contour trenching, pits and shafts, groundwater dams. So I will request to the participant, please make it a two-way communication. Please ask the question whenever you feel the difficulty during the presentation. However, at the end of the presentation, there will also be a question answer session. In that, participant can also ask their questions and clear their doubts. I will also request to the participant, please keep mute your microphone during the presentation. If you have any query or you have any questions, please ask the questions with the permission of faculty ma'am. Otherwise, this will be a disturbance to all the participants if we cannot mute ourselves during the presentation. So I will request to the participants once again, please keep close your microphone during the presentation. Today also there will also be a 15 minutes time break at around 11:15 to 11:30. And in this training program, we have already received nomination about 200 of the participants. So this is a big number in our online training program. So I will request to every participant, please listen carefully or and clear your doubts during the presentation as well as at the end of the presentation. So now I will request Minimol Korulla ma'am to start his presentation as well as her share experience with the participants.
Yeah.
Thank you.
Thank you. Thank you, sir. And thanks to all participants for taking the decision of attending this session, because the drainage is always a something underrated term. We all know that, especially for the highway sector, the drainage is very important. It's enough guidelines as well as the enough. The codes are there how to take care of the drainage in the road surface in a hilly terrain, and how it can be, how the water which is coming from the drainage, that can be, instead of making it a waste water, how it can be reused by artificial recharging or any other way of a useful resource. However, in the actual field, if we go and see in a actual field, whatever we talk in a guideline or whatever we talk in a presentation hall, that is not reflecting exactly in a highway project. So that may be the reason now IIH is every day, every year I can see that a number of courses on the surface as well as the subsurface drainage, it is getting conducted. And complicated when we talk about the drainage. It is all about the water flow. Okay, so let me try to share my the presentation slides, which is prepared on the basis of the syllabus IIH is prescribed for this course. Is it visible?
Yes, ma'am. Visible, ma'am.
Okay. Now also? Is it visible now also?
Yes, ma'am.
Okay.
Yes,
And just,
visible, madam.
right. Just tell me one more thing, whether the slides are moving. Is it moving? So the first slide is
ma'am.
okay. The first slide is subsurface drainage and groundwater recharge. That is the title slide, and then it is the second slide is the topics to be covered. So both are visible, right?
Ma'am,
First
actually,
slide is
Ma'am,
visible, madam.
full screen. Actually, this is not in the full screen. So,
Okay. Okay. You are not seeing the full screen. Okay.
yeah.
All right.
From the bottom corner, madam, you can do it. That.
No, it is not full screen now also.
Yeah, yeah, madam. Next one, next
ma'am,
one.
next comment, next comment. Yes, ma'am.
Yeah, yeah, from
Okay.
here.
All right. Okay. So, Sir has already listed the main topics which we are covering. It is actually sources of moisture in lower layers of poement. Okay. Then treatment of subsurface moisture, GSB drainage layer, geosynthetic composite, how geosynthetic composite can work as a drainage layer. We are more aware of the filtration as well as separation, but how it can be used as a drainage layer, and whether it is equivalent to a gravel drainage. Then fin drain, which are very sleek geosynthetic drains, which can be used like a French drain. So the fin drain, how it is defined in the IRC codes like IRC 34. Then subsurface drain for intercepting seepage water in hill terrain. So in the hilly terrain, it is the drainage is becoming a little more multidisciplinary subject, because one has to be aware of the geological, geomorphological, and geotechnical properties apart from the hydrological characteristics of that area, to decide that how the drainage network need to be planned. And with the practical implementation concepts, how we have to decide that the subsurface drain uh, should be planned, because in the when we are going the hilly terrains, it's very important the drainage, but at the same time there will be implementation difficulties will be there. So the planning has to be quite perfect, otherwise it will be like a trial and error, which will end up with a lot of unwanted expenditure. Then capillary cutoff. The capillary cutoff should be whether it should be a permeable material or a impermeable material. and at what should be the location where it should be placed. Then simple aggregate drains, maybe in the highway sector we are using a lot, but apart from the highway sector, even in the peripheral areas, in the neighborhood areas, there also how it should be planned, because the drainage, it will be a continuous system. It's not about just we should plan what is the drainage we need to be provided in pavements and shoulders, but even the nearby areas how it should be planned, that also is important. Now coming to the groundwater recharge, it's about the concept of how this draining water can be reused, okay, without causing, because water getting stagnant, it can cause detrimental effects to a road. Okay, so that is why we want to channelize it. But when we want to channelize it, we need to think about not only the diversion point of view, but how it can be reused, so that a holistic model can be model can be developed, which will be really ensuring the sustainability of the nature. Okay, and what are the different types of the recharge arrangement? So many types are there, but basically the IIT is asking to discuss on the different types of common arrangements, like pipes and shafts, or maybe check dams, percolation tanks, pits and shafts, and groundwater dams. Okay, very simple type of the groundwater recharging measures, so that we all will really think about it while we are planning the drainage measures. Okay, so the significance of drainage, I'm sure that it must have elaborately mentioned during the yesterday's session. But for when it is coming to a highway engineer, the most important, the technical aspects, when if water we are allowing it to act without any control, it can really deteriorate two very important aspects, which is ensuring the quality of the road, the payment, as well as the durability of it. The durability that the nowadays we think about the life cycle cost, not about what is the only the initial cost. So the water which is infiltrating will be creating the loss of subgrade support, as well as the reduction of granular layer stiffness. So its strength as well as the resistance to deformation, or the resistance of the modulus values, that will really create a big question mark on the durability and the performance of a payment. So definitely there should be a control for the water movement, and for that we have to have a preliminary idea of how the water moves in earth surface, especially if it is in a hilly terrain. When we want to construct a road between a hillside and a valley side, something like this. Okay, and then we really have to understand that whether there is a reservoir, whether there is a aquifer, and whether the aquifer is confined or unconfined. And when the seepage, if the seepage is there, the what will be the rate of seepage, and that again depends on the type of strata, whether it is a permeable strata or a impermeable strata. If it is a rock, whether it is a weathered rock or unweathered rock. And if it is a weathered rock, how will be the different types of joints or fissures. So all these will influence the water percolation and the seepage within a hilly terrain. And it's so important to understand this and map it well, so that we will be able to optimize our design as well as the implementation of the drainage network. Without understanding this, if we just tell that let us have some subsurface drains here, some open drains here, some tubes here, and some drainage galleries there, that will end up creating deterioration will be. So, the story of moving water within Earth's mass, definitely we all are having the basic idea on how it, from where it will move. First of all, if the gravity flow, for the gravity flow, that is the majority of the flows what we are seeing in the nature, it may be gravity flow. So wherever a slope is there, the force of gravity will take the water to from a upper place to a lower place. Second is, in some areas there the water can be moved, water may be moved in natural ground also due to some pressure, because of so many factors, maybe the geological factors, there can be a water collection which may be subjected to a pressure, and that can create a movement. Then the third, the man-made activities can create a pressure, and through that pressure the water can get moved. So the first, when we are visiting a site where we have to decide a drainage system, the the step one is to understand the story of moving water. It will be having a story. It may be having a history, but it, more importantly, it may be having a story which is currently running, and that need to be understood. And to understand that story, we really have to see the dots. That dots will be maybe the slope, the levels, the interruptions, maybe the existing drainage. There will be, if it is an existing road is there, we are going for a road widening or a parallel road, there may be an existing drainage there itself, there may be culverts, there may be the pipelines. So understanding that how it behaves, whether it was functioning, whether it got shocked, whether it is really having the tendency to block, even if it is at present it is not chopped, but still whether it is having a tendency to block in the future. So understanding all these are so much important, rather than just blindly we are giving a drainage plan, thinking that this is a very insignificant part of a project. So now coming to the sources of moisture in layers of pavement. Okay, so we all know that even maybe a 5-year-old child can also tell that what are the natural sources of water on earth. Okay, but what IRCSP 2014, that now that is in the revision, the H4 committee is working on it for the revision, but it is still a classic code. The 2014, it was the first revision, and it is describing about the different sources of moisture in pavement layers. So let us see what are the bullets. From poor quality bituminous mixes which are permeable. Okay, so the first itself, if the our asphaltic layers are pervious, definitely that will be causing the infiltration. Second, the if the potholes or the cracks and joints which is appearing, even if it can be just hairpin cracks, but that can create the moisture infiltration. And when the moisture is infiltrating, the pavement layers will get deteriorated, and these cracks and potholes will become wider and more dangerous. Then from the failed joint seals of cement concrete pavement, okay, so definitely nowadays we are moving to the cement concrete pavement, cement treated base, cement treated sub base. But when we are going for all these rigid pavements with a lot of advantages, there are some risk also. That's it can the especially the joints, if we are not taking care the proper the design or the proper the quality maintenance of the material as well as the installation is not maintained, the joints can create problems, and that joints can be the sources of water infiltration. Again, the between the pavements as well as the shoulder, okay, so it's again the pavement, the below the pavement we are taking every quality control, and if the shoulder is ignored, the shoulder maybe there is a ground improvement requirement, but we are doing only the below the carriageway, or maybe the even the draining layer, for example the sub base, the sub base layer we are giving up to the shoulder, and then for the shoulder we are not at all taking care what is it and all. So definitely that can create a maybe a differential settlement or a differential situation, which may be creating a longitudinal crack or the longitudinal differential situation between the shoulder as well as the carriageway. And through that, the water can be, the moisture can get infiltrated. Then medians and shoulders. Okay, again medians. We nowadays when we are going for the multiple lanes, definitely the medians and shoulders are getting more and more importance. And nowadays we are beautifying the medians and shoulders also by planting trees, by making the lawns. But again that can cause if it is not properly planned and constructed, that can cause the infiltration of water or the water flow, and which will create the drainage issues. Seepage water from the adjoining the cut sections of hilly terrain. As I mentioned before, the hilly terrains can cause a lot of issues. Hilly terrains, if properly not taken care, the drainage pattern, then definitely that can cause a lot of issues. And in the hilly terrain, especially the neighborhood has to be well studied. So starting from the complete catchment area mapping up to the mapping of the hillside as well as the valley side adjacent to the hill road, it's so important. So it's not about just a roadside drains, it's about the drainage network what we have to give in the hillside of a hill road as well as the valley side of a hill road. By understanding the complete hydrology, then only we can take care of the moisture movement. Okay, so in a hilly terrain, if we are not attending the proper continuous drainage, that can cause the moisture infiltration in different layers, and that will definitely affect the pavement layers too. Then if again in a hilly infrastructure, if agricultural lands are above the road surface, or not only agricultural lands, anything which is having holding the water, if suppose a dam is there, or a canal, irrigation canal is going parallel to the road, or agricultural land, or even a septic tank, so all these can cause a water infiltration, which may be getting ignored many times. Okay, it may be the highway engineer will be just as looking at the his department boundaries, whereas it has to be the adjacent areas which is having the influence on the highway that need to be studied. Then from capillary rise of moisture when water table is high. So we were talking about all more about the from the surface water or from the higher level how it is infiltrating. Now again there can be complete movement from the groundwater table. The water can rise, and such type of capillary rise can really create the moisture source for the deterioration of the pavement layers. Okay, so what will happen? So when all these moisture layers are coming to the pavement, so what are the different types of problems, whether it is a hill road or whether it is a plain road? Okay, so I'm just keeping 1 minute silence so that you all are at least seeing the text, rather than maybe the images are not clear, but at least you are able to read potholes, uneven sinking, rough road surface, cracks, washed away due to flash flood or the toe cutting in a hill road. Okay, so just let us imagine for a while how the water must have created these issues. Okay, how the water, infiltrating water, has created a problem for especially the creating a pothole or creating a uneven sinking or subsidence or cracks also, different types of cracks, longitudinal cracks, transverse crack, alligator cracks, reflective cracks. So all these type of different cracks, or then a complete washing away due to a flash flood or a toe cutting of a hill road. Okay, so just imagine for a while how the water will play here. Okay, then we will talk about how we have to make the drainage arrangements so that these type of disturbances can be minimized. Okay, I'm sure that everyone has just seen the images, even if it may not be so much clear. Okay, so let us think about the first one. Here we are seeing a lot of cracks, and then in the other photographs also it can be seen about the pavement deterioration in different levels. And many times this will not be the water alone will not be the cause of deterioration. We know there are other causes also will be there. Maybe the traffic load, whatever which is designed, beyond that the traffic load is happening. Okay, or maybe some of the areas are very slide prone, or an earthquake which was not predicted at the time of the design, that is happening, or there may be a liquefaction, or there may be maybe a leaching out of the intermediate layers is happening. Okay, but when the improper drainage or the improper infiltration is supplementing this type of problem, the problem will be the risk will be increasing in, not in arithmetic progression, it is getting into geometric progression. So that is the power of water, unchannelized water, which can happen in a highway or a pavement. And one more the aspect is that many times it will lead to unrepairable situation if that is not taken care at the right time. So if we are leaving it, ignoring it, the drainage issues or an infiltration or a crack which is at present we are seeing and water is okay, let it go, we might be reaching to a unrepairable situation. Maybe with the introduction of few pipes or maybe a small infiltration gallery, we may be able to control when we are seeing a subsurface drainage problem from the initial phase. But if you are leaving it and that is causing a lot of cracks which is extending to the different layers of payments, and which is means going up to even the subgrade level, then it is like that the entire payment may have to be taken out and we have to rebuild it, which may be causing a very huge reinvestment. So in that case, definitely we maybe doubling the overall cost and the discomfort to a lot of passengers and the cause of the complete the loss of confidence on the highway engineering fraternity. So now one more aspect, as I told that the strength, the when the water is going through the payment layers, it will lose the subgrade support, as well as it will be reducing the stiffness or the modulus values of the payment layers, which means that its durability will be totally affected and its performance will be affected. So one more factor, especially where the traffic loads are quite high, the the presence of water will be so much affecting the dispersion angle. So the load, the traffic load, whatever it is the payment has to bear. And we know that in a heavy traffic area, it is not just one time direct load. It is about we need to see the effect of the cyclic loads. Okay. And when these cyclic loads are happening, the dispersion is not there, and it is directly the pressure is getting exerted to the different payment layers, that will be causing a sudden deterioration of the payment layers, and the life of the payment will be shortened in a very drastic manner. Okay, so this also is something which is the detrimental effect of the water presence. Now let us see that the where the a road is constructed in a waterlogged area or in a flooded area, what the IRC code is speaking about the level of the water table, okay, or what should be the road level with respect to an existing water table, and we need to see the high floodwater level, right? So it is not about the normal water level or low water level, but the high floodwater level we have to understand. Okay, so the IRC 34 is speaking that on new roads, the aim has to be definitely to construct the road level above the water level. Okay. The existing roads, there may be limitations how much we can raise the road levels due to the adjacent there may be the residential buildings as well as the commercial buildings, where if we are raising the road levels, that may be affecting the comfort level of the people there, as well as there may be a lot of utilities might be there. If we are raising it, the entire the utilities also has to be changed. So in that case, we do have the restrictions in a particular place. The roads are existing, and by the numerous factors, the flood levels has raised from the previous years. If we are seeing that maybe because of global warming, because of some other reasons, if the floodwater level is going on getting increased in several parts of our country, and in that case, there may be having restrictions. But for a very new construction of the road, the high flood level HFL above that means honestly almost uh, 500 mm above only the subgrade need to be placed, and preferably 1 meter. Okay, so this is what IRC 34 is telling. That's to prevent the moisture infiltration, especially the subsurface water in movement. This has to be a guiding principle. And the a phenomena called piping. Okay, so this is something which is a multidisciplinary subject between the geotechnical engineers and hydraulics engineers, but this causes the piping phenomena is a very important factor especially in the when we have to construct a highway over poor quality fields. So wherever the piping is there, then a proper way of the different types of the filters or the drainage measures need to be selected so that the piping criteria will be controlled. Okay. So we will come to the analysis and design part of the drains. So that time we will talk about the piping criteria also. So I'm little skipping now, so that we can go to the other basic ideas about the drainage. So this images are taken from the Hill Road Manual IRC 48. So the IRC 48 is talking about the subsurface drainage on a hill slope. Okay. So on the hill slope, as I mentioned that the subsurface flows will not be a very simple type of definitions we cannot give, but there are the numerous terminologies are there. So I'm just introducing the different terminologies which is being defined in IRC SP 48, which is the Hill Road Manual: blanket drain, chimney drain, heel drain, intercepted drains, cutoff trench, continuous trench subdrain, collector gallery. So these are few. Okay. So IRC SP 48, if you're seeing that there are so many illustrations are there, so many the examples, even live examples, those are being given in IRC SP 48. So I will recommend that you, and even the terminologies are defined also very properly. Okay. So if you're taking that, the next 3 hours we will be talking about the terminologies in IRC SP 48 only. So I'm not going to that. It's all quite simple way it is described there. But let us see that the how the mechanisms work. So this is an indicative hill road where we are having a hillside slope as well as a valley side slope is there. So when we know that we have to provide the drainage in such a way that the road is minimum affected, as well as the hillside slope as well as the valley side slope, both also should be intact while we are channelizing the water. Okay. So in this particular illustration, we can see that for the hillside drainage, they have given a inclined drain, then another inclined drain, then there is these two inclined drains which are being given for the hillside slope. Those are very long drains, very long drains. It will be really difficult to insert these drains. Okay. Because there may be rocks, there may be the different types of strata which may be difficult to get drilled. But if you are seeing that the the drainage can cause the deterioration of the hillside slope, and the drainage is the most significant force, then we have to do it, because if we are not doing the proper drainage, this slope may be failing, and to restore that we have to spend more money. So it will be better to do the drainage and release the pore water pressure here, rather than constructing some other way of reinforcing the slope by nailing or bolting or creating a retaining wall. The drainage, if we are providing that, maybe even if it is difficult, it may be only 1/10 of the cost of all other type of measures. And once we are providing the drainage, again some way of slope protection and stabilization may be required, but the overall the stabilization measures, the cost will be drastically reduced. So now the second question is, why are we keeping it so much inclined, such as steep slope, if it is to be given? Yes, sometimes we may have to give. It will depend on the type of slope which need to be provided, will depend on several factors. Okay. So it may be because of the seepage path is like this. So we are deciding that it can be inclined in the same way, so that the maximum capacity will be attained with the minimum number of drains. Okay. Another reason is that there may be an aquifer here. So from the aquifer, we are directly taking to the down. Okay. And if we are taking it horizontally, maybe from here, a big waterfall will be happening. And that waterfall may be again disturbing the top. So that may be another reason that we are taking it to from the upper level to the lower level. At the same time, we are creating some pipes of short length at the top surface of this cut slope. Okay. Now we can see that from the rod level, a cutoff trench is provided here, because in the rod surface, a lot of surface flow is coming, and if that's the surface water, if we are allowing it to percolate, that will be causing a lot of moisture problems. So if we are providing a cutoff trench, the cutoff trench will be collecting the water from the plain surface, and it is taking it is the water will be taken to a collector gallery at the bottom. Okay, so this is what this illustration is telling. This is a particular situation from the practical aspects of that area. They have decided like this. Okay. See, another case we can see that here a significant type of drains are provided. We can see that a caisson drains as well as a drainage gallery.
Ma'am,
Those are created. Excuse me.
ma'am, ma'am, slides are
Yes.
not moving, ma'am.
Okay. Which slide you are seeing?
मैम मैम
Can
आप
you?
दोबारा शेयर करिए प्लीज.
एक्चुअली
Okay.
मैडम आपका जो स्लाइड है ना, स्लाइड नंबर 2 पर ही स्टक हो रखा है.
Okay. Slide number?
Two.
Which one?
Yes, ma'am. Sorry to
Slide number
interrupt.
2.
Yes, it's stuck on
So
slide 2 only.
slide number we are only seeing on your only
No,
slide
no,
number 2. Now, yeah.
now it's
मैम प्लीज मैम
another
फुल
slide.
स्क्रीन पे कर दीजिए.
It's
फुल
slide number
स्क्रीन
14 this time.
Okay.
मैम फुल स्क्रीन पे करिए.
Yeah. Can you
No,
see the
no,
full
madam.
screen?
नो मैम.
Ma'am, it's
Okay.
stuck on slide 14.
Oh,
मैम
okay.
फंक्शन F5 प्रेस करिए.
Okay. Can you see the full screen?
नो मैम.
No, madam. Actually, madam, बॉटम में जब कॉर्नर में आएंगे ना, बॉटम में राइट कॉर्नर पर ये यहाँ पे क्लिक कीजिए
Yeah.
मैडम.
Can you see the full screen?
No, no, madam.
Yes, madam.
Okay.
Yes, madam. To see this full screen for one slide.
Yeah. Are you seeing the full screen?
No, ma'am.
नो मैम.
Madam, please make a click, 1 or 2 click, then it will be.
Okay. Not okay?
No, madam. Madam, can you reshare your presentation? I think.
1 minute. Yeah, I will
There is some
stop
stuck.
sharing and reshare again. Okay. We'll find the solution. Okay. All right. So, Can you see it?
Yes, ma'am.
Is it moving?
Yes, ma'am. Ma'am, full mode पे कर
Okay.
दीजिए, full screen.
Yeah, but at least means unless you see it, okay? Because I think that that full screen I am going, it is creating the issue.
Okay, ma'am.
Okay.
No
So
problem. Please continue.
yeah. Okay, I will go through the at least the slides once, because whatever you have not seen. So you were seeing only up to the second slide, right?
Yes.
Hello, participants. All right. Okay. So I talked about the different types of moisture sources from IRCSP 48. Can you see the slide?
Yes.
This
Yes,
is
ma'am.
movement of water within Earth's mass. Okay, how it is going. Okay, we have seen. So these are the different types of problems. What if the drainage is not proper, like potholes, uneven sinking, rough road surface, the different types of cracks. Were you able to see? I know that you are not able to see the complete screen, but at least you are seeing. Yes or no?
Yes, ma'am.
Oh, okay.
Yes, ma'am.
Okay. Now, when it is coming to the cracks, the different types of the water movement can cause different types of the cracks. Okay. So, from observing the cracks, water or whether the subsurface water is creating the problem, and how we have to rectify it. Okay, how we have to rectify it. There are different ways of taking out the water, but it's requires that if a careful mapping when somewhere a deterioration has already begun. So the slide which I am currently showing is the dispersion angle. Even the heavy traffic is there, the water can create higher problems. The dispersion of the traffic load, that will get affected. Instead of getting dispersed, it will go. Excuse me, any problem? Yeah. Are you seeing that slide where dispersion angle for the tire pressure to spread will get affected? Are you seeing that? Yes or no?
Yes,
Hello.
ma'am.
Right. Okay.
Yes,
Okay.
madam.
Then we talked about piping. Piping is another serious issue. When subsurface water flow is there, there can be piping, and this can cause the pavement deterioration, and even the entire road can really get uh, damaged because of the piping problem. Not only piping can cause roads to fail, railways to fail, airports to fail. Okay. So, but we will talk about piping in a little later in a detailed way. Okay. Now, I was talking about the images and terminologies which are given in IRC SP 48. Okay. Can you see the two images of the hill slopes where the road is between a hill slope and a valley slope? Can you see that?
Yes, ma'am.
Right. So I was talking that the hillside, the horizontal pipes are given, and these horizontal pipes we can see that it is of different length and different in inclination. Are you seeing that? Okay, different lengths and different inclination. It is not like parallel and with the same length and all. The reason is the geological behavior in a hill slopes, that will be having different types of aquifers, different types of seepage path, and different types of the infiltration properties for this strata. So accordingly, one has to decide that how the drainage need to be provided. Okay, and for this, definitely we will not be able to just to see the photographs by sitting in a office room and decide that how we have to give the drainage in a hill road. Definitely one has to visit the site. Apart from that, lot of data collection has to be there. Okay, starting from the catchment area mapping, which nowadays one can do with the drone survey and all, or at least to do a topographical survey. If drone survey is not there, okay, a simple topographical mapping, that will be helping to understand the surface features. From there we may have to really go to the geological studies, maybe some geophysical test to understand that what are the different layers. Okay, so what are the geophysical tests which we all learned. So there are seismic refraction methods are there, electrical resistivity methods are there, which either through the sound waves or through the electrical means, we are seeing that how the different strata is is embedded in the underground, and through that we will be able to understand that the drainage or the how we can provide based on the seepage behavior or the flow characteristics of the water in these particular areas. Okay, so based on that, it has to be decided that how we have to place the pipes or the drainage holes so that the water drainage will be maximum. Now we can again see that this is one case. This is not like that in all hills we have to give like this. Okay, then we can see that there is a drainage, a cutoff trench is given in the rod level, which is again collecting the surface water as well as the subsurface water. It will be having means the holes, through that the surface water, sorry, subsurface water will be getting infiltrated to the drain, and it will be taken to the collector gallery. Okay, now we are seeing the second image. Can you all see this, the bottom one? So this is also from the Hill Road Manual IRCSP 48. It is getting revised now, but these illustrations are still, it will be maintained, because these are the classic examples how in a hill road we have to think about the drainage mapping. Okay, so the bottom illustration, the bottom sketch is talking about showing the different types of vertical and inclined drains provided for a hill drain to enhance the subsurface flows. Okay, so what are the different types of the vertical and inclined drains which are provided in the bottom sketch? There is a caisson drain is there, then a drainage gallery or a withdrawal wall is there, then again we can see the chimney drains. Okay, so what are chimney drains? Chimney drains are the vertical drains which will be carrying the water vertically, which definitely will be helping a very efficient movement of water. And the chimney drains can be made by the the most common the drainage material, which is our natural gravel or aggregates. So the chimney drains, when we are designing, its cross section can be changed as per the height of the slope. Okay, so at the topmost level, we can reduce the thickness to say 200 mm, and at the bottom part, it may have to be say 600 mm or more than that. Okay, so I have seen last week a slope which is being failed, and in that chimney drain, it is for the slope stability. The designer has provided the chimney drain, but he has provided for the entire the 15-meter slope 200 mm only. So for an aggregate drain, 200 mm is quite inadequate. Preferably it should be, say, 600 mm, but at least 300 mm has to be there for an aggregate drain. Okay, so just giving some drainage will not be giving the adequacy of the drainage. It need to be properly designed based on the discharge capacity, based on the slope, based on the infiltration the capacity of the different the soil components or the strata components. It has to be designed. Okay, or it can be like, here we can see that this is called a heel drain. There we can see that a series of drains are being provided, and it's having the triangular shapes. Each of the drain is having a triangular shape. Then at the bottom of this slope, okay, where the soil, which is a filled up soil, and the demarcating with the existing strata, a blanket drain is provided. Okay, this is again a horizontal gravel drain, and it is provided in a horizontal fashion, and the water will be moving with the perfectly with the gravity, and this type of drain is called a blanket drain. And at the end, a toe bench is there. Okay, so again, these are very indicative the drainage pattern which is sketched for a particular hill situation. Okay, but in each situation, an engineer should be able to put the common sense first, and from where the water has to flow from which level to which level, based on the various data which is available. And at the same time, everything cannot be done just with the common sense. Definitely we need to do the engineering part also, the calculations, what should be the discharge and what should be the slope, whether it has to flow completely with the gravity, whether we can manage, should we apply some other force like the pressure condition or something, whether to make the drainage to happen, whether geologically sensitive areas are there, so accordingly we may have to distribute the drainage and all. Okay, so now the sketch which is shown in IRC 34, we were seeing IRC 48, which is exclusively written for hill roads. Now I am coming to the IRC 34, which is more about the situations where the roads are in a flooded condition or waterlogged condition. Okay, so IRC 34 also is giving a sketch which is for the hill roads. Can you see this sketch? Drainage in hill roads, IRC 34.
Yes, ma'am.
Okay. So what is it about? So it is again the same type of concept what IRC 42 is speaking. But here we can see that a subsurface drain which is shown and through the bottom of the cut slope. Okay, so that is joining here, and this is our road. You will not be able to see my cursor, right? Okay, uh, so can you see the pavement layers? Is it clear?
Yes.
ma'am. Yes, ma'am.
Okay, all right. And see, you can see the triangular drain, the rod edge drain, 5.9 meter table drain, 1:4 it is written. So this is the surface drain. All right. So I'm not going to the surface drain because it is covered in other lectures. I just want to tell that, a comment on the surface drains. In the hilly terrains, whatever IRCSP 42 is speaking about, and even the other codes are telling, many times it will be very, very, very difficult to get that much space. Okay, because in a hilly terrain, you can imagine that if you are telling 5.9 meter, you have to give for the drain, then your carriageway will get sacrificed, right? So it will not be practically to give the whatever the guidelines are telling the same way the surface drain. So it may be appropriate to split the requirements in the surface as well as the subsurface drains. And in many times, it may be a certain overlapping will be there between the surface drains as well as the subsurface drains. Okay. And in such type of places where we will not get enough space for the surface and subsurface drains, there comes the relevance of the alternate materials like drainage geocomposite and all. If we can incorporate the geocomposites in places where it will be so difficult to get space, then we can solve this problem. But at the same time, when we are going with the aggregate drain, the demerits or the disadvantages are already, we know 100%, because for years and years we all are very much familiar with such type of materials. But when it is coming to the new technology materials like the geocomposite drains, which are polymeric products, then many of the merits and demerits are known, but many are yet to be clear to the road engineers. Okay, so we'll come to that. Before that, this is another situation which is illustrated in this figure, which is again taken from IRC 34-2011, figure 8.4. This is a particular situation, a road surface again in a hilly terrain, where the hillside, there we can see that different types of terrain are there. There may be a impervious rock. Above that, we can see a pervious layer is there, and then again a overburden is there. Maybe a little weathered rock. Okay, so a complete impervious rock, and then there is a pervious rock, and in between a completely pervious layer is there, which if we are not interrupting that, it will act as a seepage layer, which will be causing the deterioration of the hillside slope, and that will definitely will be affecting the road safety. Okay, so in those type of cases, we may have to create the drainage gallery, which we have seen in the IRCSP 48 illustration. Also, we have seen the drainage gallery. Okay, so the IRC 34 is also repeating that we may have to give in hill roads for the hillside slopes as well as the valley side slopes, apart from the horizontal or inclined pipes and the roadside longitudinal drains. We may have to put this type of intercepting drains like drainage galleries. And these drainage galleries, is it a surface water drain or subsurface water drain? It can collect water from here if there was an impervious cap is not there. But we are putting an impervious cap here so that it will act as a complete subsurface drain. Okay, so why it is being recommended for a impervious cap there? So the answer is, if we want to make it as a drain common for surface and subsurface water, then either the drainage capacity of that the gallery should be so high because it can collect both surface as well as the subsurface water. Okay, or it has to be repeated at a very close intervals. And it is not easy to construct drainage galleries in a hilly strata, especially when the rocks and soil and different types of stratas are encountered in the same place. So we have to make it, if it is to be optimized, then we can separate the surface water drains and subsurface water drains. Surface water drains, we can go with the simple tube system, open drains, and it will collect the surface water. And subsurface water, as we are plugging it at the top, the drain will be purely for subsurface purpose. And then we can optimize the size of the subsurface drain. Okay. So there are some more figures are there, which is again talking about the concept in a hill road. This is from IRC 34 only. So the IRC 34, the left side sketch, it is showing that instead of one single pervious layers, maybe we can go for two pervious layers. And the front face, if we are providing a retaining wall, the retaining wall, preferably it should be a self-draining retaining wall. Okay, if the height is not much, if it is only 1 meter or 2 meter, we can go for a dry rubble packing. Okay, the masons should pack it properly, but we can go for a dry rubble packing. The dry rubble without any mortar, without any cement mortar or anything, the dry rubble packing is given as the retaining wall. It can go to 2 meter or 2.5 meter. Then the with the some previous layers as acting as the horizontal drainage, and with this the previous type of retaining fascia, the water will come out. If the height is more, it's more than say 2 meter, then we can go for a gabion fascia. Gabions are rectangular cages, which can be filled with stones, and each gabion box can be connected to adjacent gabion box through lacing. And once it is connected, it will act as a monolithic structure. So that is again a free draining structure. So the gabions, if we are giving instead of the dry rubble wall, then we can go to higher heights. Okay, higher height retaining wall can be constructed. So the gabion, while it will act as a toe retaining wall, it can act as a free draining support also. Okay. Now in the right side, what is the figure? So in this case, it is not a retaining wall. Okay, there is a rod. We can see a two-lane rod, and then there are surface drainage systems are there, longitudinal drains are there, and then in the hillside we can see it is perforated pipes are there. Then a concrete capping beam is there, and in between portion, those are uh, protected. The slope is protected by pitching. Okay, so the pitching also is free draining. It is only the stones. Okay, so the if stones are available, okay, good quality stones as per IRC SP 89 is available, we can go with the pitching. If stones higher type of stones are not available, we can go for smaller stones, and it can be placed in a mattress. What are mattresses? Mattresses are like I said about gabions. Those are rectangular boxes which are made with steel wires, and those can be filled with the stones. So those mattresses can also be used as a slope protection. So the gabion, like gabions, mattresses are also permeable, and it can act as a phase draining measure. Okay. So now if even smaller stones are not there, then we cannot go for even mattresses also. In that case, we can go for erosion control measures. Okay. So those erosion control measures also, if it is free draining, that will be ensuring the slope stability in a better way than the other types of slope protection measures. What are the other types of slope protection measures which are not draining? If we are going for a cement concrete lining, it is not free draining. If we are going for shotcreting, it is not free draining. Okay, so it will be better to go for free draining slope protection measures so that it can release surface water as well as subsurface water. Now, simple aggregate drains. Aggregate drains, suppose if a highway is going parallel to a complete agricultural land or a recreation area where lawn is there or vegetation is there. So in that areas also, the surface water as well as the subsurface water, if it is not regulated properly, that can create problems for the road which is nearby. Okay, so the surface water drains that can be created in those case by simple making the the uh, the horizontal as well as the vertical drains and filling with aggregate, that can create good drainage system, and that was the original practice. Okay, but nowadays the aggregate is becoming so costly material, so definitely for the surface and subsurface we have to find out the options. So I'm little skipping the aggregate drains because our concentration is subsurface drains. So this is again an indication. Can you see this? So we can see the different layers of a paved road where paver blocks are used as the paving material. Are you able to see this? Okay. So
Well,
yeah. So the now it is 11:05. Your break is 11:15, right?
Okay, madam.
Right. Okay. So what is the indication here? See, we are showing the different aggregate sizes. Okay, different aggregate sizes when we are going for base course as well as sub base course. Uh, so the how these aggregate sizes will be influencing the drainage efficiency. Okay, so where we can get the guidance on that. Okay, I have gone to the next slide. This is again taken from IRC 34, the image. So water table, if we want to lower the water table in a flooded area or a waterlogged area, what are the ways? There also the subsurface drains is the solution. One of the solution is the subsurface drain, which is simple, which is not damaging any nearby areas and all. Okay, so why I am telling this, see, we can, there are other type of drainage measures are there, like pressure, by means of pressure, vacuum consolidation. So we can suddenly we can reduce the water level, okay, in a flooded area and all. But the issue will be when we are going for vacuum consolidation and all, or the vacuum drainage and all, maybe a sudden movement can happen. Suppose a highway is going and we are using the vacuum methods where we are suddenly drying the water level through by applying the pressure, then the relative subsidence which can happen, that can cause cracks in the pavement surface, cracks in the adjacent buildings. Okay, so the simple aggregate drains or simple subsurface trenches, that is still the popular method, as they may be working gradually, but they may not be causing a sudden surprises. Okay, so this is again the image is from the IRC 34. Here the importance is when we are creating a series of subsurface drains for reducing the water table level, then the most important part is the how much is the depth of the drains and what is the spacing. If these two are not defined, then definitely the installer or the contractor will not be getting the idea how we have to go for the subsurface drainage. Okay. And the spacing is quite critical, because if the spacing is not proper, wherever we are thinking of reducing the water flow, the water table level, that may not be really giving the reduction. Sometimes it may be the causing very half-hazard type of the results. Okay. So how we have to design the subsurface drainage in a waterlogged area? It requires the specialist, someone who is knowing the geotechnical behavior of the soil, as well as the hydraulic aspects also. How the flow within the soil will happen. Okay. If, when I am speaking about a specialist is required, that doesn't mean that okay, somebody who is having post graduation or PhD has to be there. As a basic civil engineer can do all these things. It's only requiring the awareness about the local soil and the awareness about the flow paths, what is happening in a particular locality. So now we will go to it is basically we want to talk about this after the break. But before the break, we are having 5 minutes. So I will just give you the introduction of the geosynthetics in drainage application, as that is also a part of our today's syllabus. So before I'm talking about this particular slide, I am little moving ahead. Yeah. Can you all see that I have taken to the slide which is showing the different types of the geosynthetics. Is it visible to you, the images? Geotextile, geogrid, geocell, geomembrane, geonet,
Yes,
geomat?
ma'am.
Okay, fine. All right.
Very clear.
Okay, fine. So in this, what is important for us is none of the product which you are seeing. Okay. Uh, what we are taking today is the geocomposite, where a geonet. Have you seen geonet?
Yes, ma'am.
Okay.
Yes,
So
madam.
this geonet sandwiched between two geotextile. Geotextile is, I think all of you know about geotextile. When we are using a polymeric fabric in presence of soil, that is called a geotextile. Okay. So geotextile can act as a good separator as well as a filter. Definitely, if we are properly selecting. Okay. So if we are sandwiching a geonet, okay, a geonet in between two geotextile, it will become a geocomposite, which can be used for drainage purpose. So now we will see that in the geotextile, okay, geotextile is acting as the first filter. Through that, water will go and then it will pass through the drainage net, and then another geotextile will be there, which will again act as the filter. Okay. So these geotextiles are different categories. There are woven geotextile and non-woven geotextile. So woven geotextiles are used for reinforcement application because its strength is good. It can have say 50 kilonewton per meter, 80 kilonewton per meter, 100 kilonewton per meter, even 200 or 300 also. So it is having high strength, but its hydraulic properties like filtration or separation is not so good. Okay. Whereas non-woven geotextile, its hydraulic properties, its filtration properties are good, its separation properties are good. Why? In woven geotextile, what does it mean? It is like a fabric, our normal cloth. it will be there will be a warp direction as well as a weft direction. Okay, so that will be produced, manufactured by weaving. But then soil and water together, it is going through the woven geotextile. Then continuous movement happens in some parts of the woven geotextile. The voids will become wider, and somewhere it will get clogged also, because water continuously going as the warp direction and weft direction, the filaments are going in a very regular pattern. Continuously when water goes through that, it will somewhere it will become wider and somewhere it will become shorter. And wherever it is becoming shorter, the soil will get clogged there. And wherever it is wider, the soil will go out of it. Okay. So when the soil is going out of it, will it act as a good filter? No. Whereas the non-woven geotextile. Now I will say what are the manufacturing methods of non-woven geotextile. The non-woven geotextiles are manufactured by heat bonding or chemical bonding, or by mechanical means. Okay, the small polymeric filaments will be randomly placed. Randomly placed means, say, hundreds and hundreds of filaments will be placed, and it will be pressed. It will be pressed by mechanical means. Then it will become a non-woven geotextile. Sometimes it will be heated. Then we will call it as a thermally bonded geotextile. Sometimes it will be chemically bonded. Okay, so in all these type of cases, cases, the non-woven geotextile will be produced. Just 1 minute. Yeah. So in all these type of cases, the non-woven geotextile, one characteristic is making it very attractive for the hydraulic applications. That's the randomness is allowing when the water is passing through that, even if the pore, that particular moment, if it is getting wider, it will again regain its original shape. So in a non-woven geotextile, when the water is flowing through that, the pore size will not get changed. So the risk of somewhere getting clogged and somewhere getting eroded, that will not happen there. All right. Now we can break for 15 minutes. Okay. We'll come back to and continue with the session at 11:30.
Okay, ma'am.
All right.
Okay.
insertion of that, and that way it will ensure a very efficient consolidation. Okay. So so this is about the subsurface drainage. We can go for the part 2, which is a groundwater recharge. Okay, give me 1 minute. What do you want? What do you want? आपको कैसे अभी नहीं चाहिए? I'm taking class. So before going groundwater recharge, any questions about the subsurface drainage or drainage geocomposite? Or shall we continue?
Ma'am, please continue.
Okay. 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 So groundwater recharge. So why groundwater recharge need to be studied by highway engineers? So my answer is like that: when we are talking about the drainage water, the water drainage may be bringing a lot of water, and instead of making it as just wasted resource, it can be used for the groundwater recharge if it is channelized properly, and the definitely as a holistic uh, designer or a holistic planner or holistic constructor, one need to think about the sustainability point of view for not only the highway but the adjacent the neighborhood where this resource can be used. Okay, so definitely we may have to know the, or we may have to, it is, we all know this is not anything which we don't know, but in the right time. Okay, the right time, that idea as well as the word has to come to our mind, so that somewhere we can suggest it, somewhere we can implement it. So groundwater recharge arrangement, the basic, the most simple, I will say that again, it will be pipes or wells. Especially we have to use the subsurface draining water. If we have to bring it to a place where it can be stored and used, we may have to use pipes, simple pipes, or we may have to use some type of wells. Okay, and it need to be seen when we are using it for irrigating lands or some other use. Definitely the quality of the subsurface water, that need to be understood. Okay, whether it is a fresh water or whether it is having some acidity or alkalinity, or it is having some poisonous nature. So those type of information need to be there. Okay, especially when some industrial areas, when we are doing a road or constructing a road, and definitely the industrial waste itself is being used as an embankment fill, or some other the infrastructure building material, then the water which is leached out from that, whether it is having any type of properties which are detrimental to human life or animal life, or uh, the plant life, that need to be known. And artificial recharge, Definitely, it is in a engineered way. It can give numerous advantages if we know the right way of artificial recharging. So one way is the check dams. Okay, so the check dams are something which normally water source department they used to use for collecting water in a stream or a river or those type of places where they want to store water or where they want to divert the water or whether they want to dissipate the energy. They used to use weirs or check dams. Okay, but in our case, suppose a hill road is going in between a hill slope and a valley slope, and the hillside, a lot of debris flows are happening. Okay, there is a lot of debris flows are happening, and these debris flows are, it is not visible to the road user. Suddenly the rain happens, flash flood is happen, the debris are flowing, and it is happening like in a under subsurface flow. So that time that can cause very huge risk, because many of this time this type of debris flows will not be visible at all, and it will be having very compared to the soil erosion or soil movement or even rock movement, this will be having very high energy, because when the rock is or debris are being moved by water, it's having the kinetic energy as well as the potential energy. So it is coming with a very gigantic type of energy movement. But if we can create some check dams in between, the debris or the silt or whatever it is, that will get stopped and the water will move. Okay, and initially the when the water velocity is getting reduced, even water also will stay there, so that area can more get recharged. Okay, so the check dams which is being constructed, I was just telling one situation. Okay, so likewise the check dams can be used as a one of the artificial recharge method in many situations. So another the recharging method is percolation tank. So what is a percolation tank? So percolation tank is the different types of surface flow and subsurface flow is collected in a wider base, and from there that it is allowed to move in a below the ground, and that can be collected in a separate well or pond or lake. Okay, so it will be collected in a wider area, and from there through the subsurface flows it will be collected in a well. From there it can be taken out for other applications. So the percolation tanks can be mixed with the contour bunds or the in the places where we have to create slope stabilities, or we may have to create the spaces which are used for the agricultural farming and the protection of the hill slopes. Now, contour trenching is again another way of artificial recharging, which is being described in IRC 34. So the contour trenching is instead of creating the wells or tanks or check dams, here we are making a number of trenches. Okay, we are creating a number of trenches and erosion control methods. The erosion control methods may be, it is a combination of grass or vetiver or live stakes, but in between we will be creating this type of trenches. And see in this farmer, he is creating a contour trench. Okay, So this contour trenches are definitely means Anasi, there should be an awareness of the contour levels, and then only the contour trenches will collect the subsurface water, and from there we can properly take it to some other places where it can be really used for some other purpose. So while we are taking the water out in the contour trench itself, we can do the artificial recharging. Okay. Now, another the engineering the principles where we can apply, that is simple pits and shafts. Even simple pits, we create a pit which is really parallel to a highway, where a hill slope is there, which is having a lot of subsurface flow. That also can really work as a artificial recharging, but the provided that the pit should be lined by some permeable material, then only the water will infiltrate. Pit should be designed, even if we are telling it as a pit, it is a engineered structure, it has to be an engineered structure. Its sides as well as the base, if it is to be stable and if it is not collapsing, then the geotechnical principles has to be adhered. Okay, so when the water is going through that, definitely there will be a change in its shear properties. Suppose if the material, because if we are really allowing a irrigating land, definitely it will be organic soil. Okay, and its friction value will be less. And if the water is continuously moving through that, okay, we are talking about the this sustainability, artificial recharging, and all these good words. But if the engineering part of us is not working, definitely it will not be a sustainable model, because when we are doing it in a massive scale, the side slopes of the pit as well as the bed need to be having enough shear strength. If that is not there, it will be having the local slips, and then leakage will be there, and then we will be ending up a very disastrous way. The one channelized pit will become a number of messy pits, which will be causing the ecological disorders like mosquito breeding and other type of problems. So it is very important, the engineering aspects like geotechnical stability, it's the hydrological stability, and even environmental stability need to be checked when we are doing this type of measures for artificial recharging. Okay. Then apart from recharge pit, if we want to take the subsurface water to a different level, then we can use different types of recharge shafts. So the recharge shafts, especially from the if we have to move the water from a subsurface drain or a uh, surface collection of water or a surface drain, if we have to move to a subsurface unconfined aquifer, then we can use the shafts. Shafts are the ideal structures which can move in a channelized way to from the surface drain to a subsurface drain. Now, groundwater dams. What are groundwater dams? If we have to create some underground barriers for the subsurface flow, then we need to design those type of dams, okay, or barriers like the check dams. Okay, but what is the difference between the check dams and these underground dams? In the check dam, it's like the every force, whatever it is, those are basically gravity driven. But when we are going for a underground dam, it may not be always, the forces are not driven by the gravity forces. So the design will be more micro level and a deep subsurface investigation and the study regarding the soil, the water, the pressure levels of the water, and even the soil structure interaction. Because what is the type of material which we are using for this underground dams? If we are using, say, concrete, or we are using a masonry, or we are using some wood material. So according to the different types of material, the soil, the structure, and the water, the how it will work together, that also need to be studied in this case. But basically, the what the civil engineer, or especially a highway engineer, need to have in this type of situation is the social awareness many times. Because the for a highway engineer, his domain is the road and the associated structures. And here we are going little beyond that, and it need to be perceived by the social system in a correct way. Otherwise, after we construct everything, it may not be used in a proper way. So the creation of the awareness, it is so important, especially for this type of structures like groundwater dams and all, because that can really change the entire ecosystem of that area. It can have some type of risk also when we are constructing the groundwater dams, because the people may not be, sometimes the next generation may not be aware that it is a groundwater dams is created there. So in that case, when a groundwater dams and all are getting created, the appropriate signboards has to be kept, so that the people will be aware that there is some groundwater dam is existing there. It need to be taken care. It need to be means, and say, if any other structures are being constructed near to that, its weight also need to be accounted, or it's the forces which is coming from that need to be accounted and all. So underwater dams are having the advantages as well as disadvantages. The advantages is it is in a very closed environment, so there is a complete control on it. It is not taking extra space. So definitely it means, and it will be having much higher life, because nobody will think that, okay, fine, let me transfer from this place to another, or let me also use this. What is the recharging? So those type of um, concepts will not be there. But the demerits of the groundwater dams are, I already mentioned that many times the people will ignore it, and without the awareness, a messy situation can be created. So only way is to educate and make the warning signs, or the signboards, so that the people around will be aware of it. So before going to the some case studies again, shall we discuss now? I feel we have to discuss. Then only we should go to case studies. So I wish to hear from all of you that what do you think about subsurface drainage as well as the artificial recharging? This is something which we all know, but are we able to implement in all the projects what we are working in a perfect way? It's a question from my side. Anyone?
Hello, ma'am.
Yes. Hi.
Yeah.
Can you please, sir, introduce yourself?
I'm Mr. Bini Pelan. I'm from Arunachal Pradesh.
Okay.
Ma'am, methodology, whatever you have elaborated and appraised, is very good. But main factor is ma'am, funding, constraint of the fund. No?
Yeah.
So we want to go for that. So many of the things, especially in our hilly areas.
Yes.
But the thing is that to adopt all those things. So, ma'am, can you just give us some idea about the cost factor, especially
Right. Okay.
according to that we can plan and we can request and we can take up with our authorities.
Right. Yeah, sir, very valid question. Okay, sometimes we all will hide this factor and we will talk about very great things and all. But finally, the fund is a major factor which is really, uh, discouraging us to take beautiful steps. But I will say that, sir, if the fund is allocated for a particular, for example, if a road or a in a hill slope or in a waterlogged area, a riverbank slope. So in all this, what we can see that the even if it is limited fund is there, in that if we can take a small percentage, I will say 2 to 3%, if we can keep for drainage, our many problems can be solved. So instead of waiting for getting an extra fund for doing everything perfectly, I will request that whatever we are having that in that, definitely because you all are representing the client organization, so you can take a decision that at least this much I will keep for, say, drainage, erosion control, because these are the part which will make the a sustainable earth for our future generation. If we are not taking care, nobody will take care. So the instead of additional, we have to think about 2 to 3% minimum. I will say I will be happy that if it can be go like 7 to 10%, but at least 2 to 3%, if we can means, and say, even especially in a hill slope and all, just a simple drainage and erosion control, lot of problems, future problems can be avoided. Because many places we make roads, then we cut vertically the slopes without drainage. So the slope itself is unstable because of vertically we are cutting, or with a very steeper slope we are cutting. And it can stand provided if you are giving very good drainage and erosion control. Okay, make the drainage as a practice, even if we are not going for very elaborate methods like drainage galleries or check dams and all. So at least we can give some benches, some vegetation, and simple trenches or simple pipes and all. Okay, now let me talk about the cost factor. As I mentioned that nowadays the aggregate is becoming very costly. Okay, earlier when I was talking about drainage geocomposite and all 20 years before, when I go to CRRI or ministry and talk about the aggregate drains, that time also everyone will listen about that. But at the end, they will tell that, see, these are good for research purpose, because these are very costly. It is coming from abroad with the 40 percentage import duty. So the cost of a drainage geocomposite, that was coming something like 600 per square meter or 700 per square meter, whereas aggregate drain, just make that much length of aggregate drain, the cost will be say 350 or 400, that much only. So definitely yours is coming as double, and we don't want this type of fancy materials. So, and it was right also. Okay, it was right at that time. Even if I was talking again, good quality control of factory, its installation is very easy. You can do it very fast. It was a fact that the material will be available in a cheaper rate in our country. Now the situation has reversed. How it has reversed? The aggregate cost in many parts of the country, it has shooted up. It ranges from 800 rupees per cubic meter to 3000 per cubic meter, and in somewhere it is much more than that. Whereas the drainage geocomposite, its cost has reduced. It is now available in say 150 per square meter to say 250 per square meter. So the same aggregate drain, 1/3 of the cost, somebody can go for drainage geocomposite, and it became a very hot material. And nowadays, the Indian manufacturers are producing it. So there is a healthy competition. It is not brought from any other country. So no import duty and all. Of course, the taxes and other whatever it is applicable, that is there. So the alternative technologies, whatever it is available at present, that need to be used. That is again my recommendation. Uh, but we will not be having a perfect situation that we will be having plenty of money and then we can implement the subsurface drainage or the overall drainage. Another is, sir, some money has to be kept for funding, has to be kept for the studies. So I was mentioning about hydrological studies are important, geophysical is important, geotechnical is important, geological is important. So I can understand that you are when you are hearing, you will get again angry. So this many studies, again, where is the fund? So again, my answer is that if at least you can consult a, a expert in the DPR stage itself. And when we are talking about 6 type of studies: geotechnical, geological, geomorphological, hydrological. See, everything will not become so important for every project.
उसको गाइड
Okay.
गलत कर तो उसको तो आप और ही समझाएंगे ना विद कैलकुलेशन
ये जब जाएगा ना बिल समझ में आ जाएगा तो आप नहीं समझते मैं समझता हूँ पहले से हम नहीं समझते जैसे कुछ बिल दे दिया ये साइड दे
Hello.
Hello.
Ma'am,
Yes.
right? Actually, by my own practical experience,
Yes.
I
Sir.
think all of my friends who are from the hilly area, they will also appreciate that. No doubt it's very costly, but if we see recurring expenditure, I think, and unnecessary time consumption,
Yeah.
so I think this method, whatever you have a price, I think it's the best method, and
Yeah.
we can just save our recurring expenditure. My own experience is that
Yes, sir.
on my request, Geo Textile, I think one Plaxita group,
Mm.
they have just constructed one breast wall in my road as a
Mm.
demo, 30 meter. It took only 7 days to complete it. But what I have noticed for the last 3 years, that breast wall is still it is existing, and I think seepages and drainage, everything it's okay. But
Right.
wherever we have constructed the RCC breast wall or the PCC wall, almost in every year it used to crack or it
Yeah.
used to damage.
Yeah.
So
Yeah.
what I feel key again for reconstruction, the same amount we have to do the expenditure. But for the last 3 years, that GeoGrid, geotextile, which the breast wall I have constructed
Yeah.
in my room as a demo.
Right.
It was free of cost. The company Plaxidab, they have just constructed that
Yes.
particular.
Right.
So I have tried a lot many to my seniors
Right.
and the authorities from the MRTH, whoever comes, I used to show it, sir, you see, this is the, if we go for this one, I think moreover, the unnecessary clearance of the lane slide or slip clearance, I think it all saves.
Yeah.
So if such type of comparison can be made,
Yes, sir.
whenever such type of lectures, if you give,
Yeah.
we can
Yeah.
also give, just support you with some of the documents
Yes,
for,
sir.
for
Right.
your lecture. I
Right.
think in this way we can convince our authority, what I feel.
Yes.
So it would be my
Exactly.
request.
Yeah. Yes, sir. Yesterday I was in ministry, and definitely it is actually member projects. He was telling that every day there is a landslide, and it is many of the landslide which has happened is already there. A lot of structures are constructed with the RCC, with the expensive structures. There the slides has happened. So I would like to say that what you said correctly, the FlexiTF has adopted a technology which is flexible. So in the hilly areas where a lot of slides and those type of tendencies are there, a lot of water leakage and everything is there. If you construct RCC, fine. If you are having a lot of material to or lot of money to waste, because RCC being a wonderful material, which is a magic material, it is one of the strongest contribution for civil engineering. But one has to understand that its adaptability to movements, adaptability to water is limited. It is a material which is quite strong in certain aspects, but it is not a material where a good material where a lot of movements are there, because its adaptability to movement is limited. Otherwise, you need to reinforce it in so strong way. It has to be reinforced, doubly reinforced, and then maybe some steel fibers also you have to mix, then it will be. Because RCC, the way we are constructing is, it is like we are finding that where the tension will be peaking, and there we are putting steel elements, and we are thinking that, oh, this is the way the bending moment will be maximum, and then we are putting. But we are not strengthening the RCC completely in every place to take the deformations. The serviceability, we are not going to that extent for the case of the Himalayas, which is having very high level of movements, which we are not seeing. We are uh, feeling the movements only when we are hearing, oh, this much big landslide have happened or seismic event has happened. Then the entire thing is washed away. Then only we are feeling that, oh, Himalayas is moving. But Himalayas is keep on moving every single moment. If you are going to Himalayas, if you are standing there in a very peaceful way, you can even understand that Himalayas is moving every minute, every second. Same way, the our entire the geological, the Indian geological condition is like that. Only very few states are having seismicity quite very much low, and every year we are having a lot of this type of calamities, movements, everything happens. Most of our mountainous region, and there we are going and constructing rigid structures which are not at all designed in a micro level for the serviceability criteria. Only strength criteria, our entire focus is there. Serviceability criteria last, okay, a small deformation check which nobody will even mind. Then definitely it will the structure will not means and say compromise or sacrifice. It will stay for what it is meant for or what it is designed for. So there the flexible systems will work. So I am showing, sir, this is actually Kiratpur NH21, because yesterday when I heard from Pandey sir, RK Pandey sir, that's the Himachal, the same road, there are a number of slides has happened and a number of structures has failed and cracks has come, and very bad way. So this is in the same rod NH21, 25-meter, 33-meter type of retaining structures are being created, but it is completely with the flexible systems. Like this Flexitef, the systems are flexible. It is reinforced soil structure, Gabion structure with the free draining fascia. Somewhere it is completely vegetated fascia, but it is completely with the geogrids, geotextile and gabions and drainage composite and all, which is free draining, okay, which is free draining, and which is incorporating the vegetation and its roots. So it is standing. That doesn't mean that these type of structures will stand forever. No, it's not like that. Here also design is required. This is a reinforced soil structure. Okay, in this reinforced soil structure, as today's subject is subsurface drainage, let me tell that how many subsurface drainage components are here. So this is a reinforced soil structure. Instead of a RCC, in that the Gabion fascia, that itself is a free draining structure. Then geogrids are going as a primary reinforcement. Then this is a subsurface drainage structure. It is a drainage geocomposite which is having two geotextiles at either end and a drainage net is there. Okay. Then there is a horizontal drainage. I don't know whether it is visible to you. A horizontal pipe is there, which is taking the channelizing the water from this chimney drain and taking it out. And at the same time, it is again taking the subsurface water from this drainage block. Okay. And this type of a structure is reducing the cost from a RCC retaining wall, even if the soil is good in both the cases, at least 30 to 40%. And if we are going for a poor soil, the cost advantage can go up to 70 to 80%. Okay, it is unbelievable, but the point is that there should be a proper design has to be there. Okay, and a proper installation need to be there. Okay, now we can see that we can use this type of drainage geocomposite and all with RCC also. So this is again another case study. Drainage composite which is being used, it is written here. And it's definitely, it has really saved at that time almost 40 to 50% of the material cost itself. Then installation cost also there was a saving, and finally the structure is really working quite satisfactorily. So we can really go for those type of options. When we really want to save the money also, then also we can do the things. But important part is that subsurface drainage need to be provided. Surface drainage and subsurface drainage are very, very important. So I was talking about even geotextile. If you are not having a drainage composite is a little costlier material. You have to spend 150 per square meter to sometimes up to 250 or even 300 per square meter. Okay, but where that much heavy drainage is not required, a mild drainage only is required, then we can go for a thick geotextile. So geotextile you can get in the range of 40 per square meter to say 80 per square meter. In that range you can get most of the geotextile. So that is again another alternative where mild drainage only is required. We don't have to go for costlier material, we can go for milder geotextile. And all these, okay, all these geosynthetics or whatever it is, it will be advantageous only when the aggregates or stones are costly. Okay, so where aggregates are plenty, even gravel drains can work, provided it has to be put in a right way. So this is another project where is it visible to you? The site situation is there.
Yes,
Can you
ma'am.
see this?
Yes, yes.
Okay. Please see the soil condition. Okay. Soil condition. It is in fact it is in Gujarat, and it is a creek. A road is constructed in a creek, and the type of soil was very bad. And there you can see that the now the carriageway that is reinforced with the number of geosynthetics, and in the side portion 2 Gavian walls are provided, which are pre-draining. Okay, and base and sub-base, those are reinforced with the geogrid, and drainage geocomposite is provided as a drainage layer, because the sub-base layer is, the thickness is reduced and a drainage layer is incorporated. Okay, so the considerations, but definitely when we are installing, we should take care of the material, because when it is an aggregate, we don't have to think about damage and all. Okay, but when we are working with a geosynthetic material, we need to see that the material is not getting damaged. Handling should be more careful. Then another the demerit of all these geosynthetic materials are, it cannot be exposed to sunlight for a long time. Nowadays, all the companies are telling it is 100% UV stabilized, but definitely there will be still some degradation will be there. So once we are taking the geosynthetics out of the roll, it need to be seen that as early as possible it is going below the soil. Okay, most of the geosynthetic products are, it is for placing within the soil. Once it is under the soil, then it will stay forever. Even if the manufacturers are telling 100 years or 120 years, the fact is that plastic will never die. After the 120 years also, it will stay. But if it is exposed to sunlight, there will be creep reduction, there will be and brittleness will come. So we can imagine, even if whatever we are using, the simple bucket, if we are keeping it in our bathroom, it will means, and see, you can see that its durability is higher. Okay, but if you keep it in open in our veranda where sunlight and heat is coming, after some time it will become brittle. The plastic toys babies are playing, okay, the baby is throwing it to outside, and if it is there for some time, it will become brittle. Okay, the plastic will change. So that factor is there. So if we want to use the geosynthetic products and all, the lesson is that it can be open. It is not like that next day it will become brittle, or it will become subjected to creep, or it will be, no. It's the degradation is very small. Degradation is say 0.001 percentage. So we will get a time once the roll is opened. Okay, fine, 40 days, 50 days, or whatever it is. Even if it is exposed to sunlight, it is not having any problem. But once it is below the soil, it will not degrade at all. If you are protecting it from sunlight, it will not degrade at all. Because within the soil, if outside 40-degree temperature also, within the soil, the temperature will be less. It will be only 28 or 27 or 26 only. Okay, in that temperature, nothing will happen. So it will stay forever. It is having much more durability than the most of the civil engineering material, provided it is protected from sunlight and heat. Okay, so thanks to all for your attention. And the topic what we were talking was about the subsurface drains. So for the subsurface drains, we can use horizontal pipes, inclined pipes. We can use the drainage galleries, blanket drains, chimney drains. In a hill road, we may have to consider a number of factors: the geological, geotechnical, hydrological factors. And for the hydrological factors, we may have to start from the catchwater, the the complete mapping. And for the finding out the infiltration rate or runoff coefficient, or the rainfall intensity. So in each area there will be the reports will be there, either with the irrigation department or the central units like CWC or GSI and on. So many of the reports will be already available, so we don't have to spend for every report. Then multi-specialists are required for the especially for the hill roads design or the drainage design of the hill roads. But it definitely, for a particular project, everything will not be peak. So we can give the importance for what is maximum important in that particular case. In some cases, we may have to go very deeply for the geological past, and maybe the service of a experienced geologist may be required. Okay, but in certain cases, that type of heterogeneity will not be there, and we don't have to go for very in-depth geological study. We may have to go for maybe some geophysical test. And geophysical test, as sir was asking, the how much will be the expenditure and all. See, for a normal for a DPR making for a certain see a half a kilometer stretch, if a geophysical test is to be done, it may be say 7 lakhs to 9 lakhs if we are spending. Then we will be knowing the strata layers, how much rock is there, whether any intermediate weak layers are there, whether any aquifers are there. So we'll be getting all this information. Once we are getting this information, then we can go for deciding the number of boreholes and the spacing of boreholes. Otherwise, at every junction, if you are providing a borehole, then that the cost will be shooting up. Okay, but at the same time, when we are doing the studies, definitely we require a minimum number of boreholes, and definitely for each borehole the cost again maybe in a normal condition, if you have to go up to say 15-meter depth, so that itself will be costing for one borehole, that itself may be costing some 1.15 lakhs. So then if the hydrological studies need to be conducted, as I told that from the CWC and all we can take, and the local WRD we can take some of the data, and it will not be for the hydrological studies. The maximum expenditure will be say 2 to 2.5 lakhs. And for doing the topographical survey, if we are not going for a drone survey, so 3 to 4 lakhs you can get a topographical survey report for a circumference of a half kilometer. But if you are going for drone survey, that also going for 6 to 7 lakhs minimum. So altogether, definitely for a half a kilometer road in a hill, at least for the whole studies need to be conducted, you may have to keep 50-60 lakhs. Okay, so it is a decision for the departments and all, whether you have to go for a proper study, or whether you have to go very empirically to go for the selection of the drainage or the retention measures and all. But as the safety is important, and the life cycle cost saving will be more relevant compared to the initial savings and all, I will recommend that a holistic study is very much necessary, and that will help to optimize the overall cost. So that's all. Thank you so much for your attention and the presence. Hope we will again meet somewhere, or maybe in IIT class itself. Thank you so much. If you are having any type of feedbacks or any questions and all, kindly convey through IIT. I'm in constant touch with IIT, and whatever the questions or concerns coming from you, definitely I will try my best to attend that.
Okay.
Thank you so much.
Thank you. Thank you.
Okay, thank you, ma'am, for sharing your experience as well as the presentation with the participant. The participant will get the benefited from your lecture, ma'am.
Thank you.
If the participant have any questions, please share your question on the WhatsApp group. We will share your questions with the madam and try to take the answer of all of your questions.
Sure. To the best of my ability, I will definitely answer that. Kindly share in the WhatsApp group or in the chat form. Thank you.
Yeah.
Thank you.
Thank you, madam.
Thank you, madam.
Thank you,
Neeraj,
ma'am.
now please finish the meeting.
जी सर